Hello guys, I hope you are doing great. Today we are going to talk about electricity. And before we start talking about electricity, we need to talk about an atom. So, an atom consists of protons and electrons. As you can see here, in the middle, we have the nucleus. In the nucleus, we have protons and neutrons. The protons are represented in orange balls and the neutrons are represented in the gray balls. And an atom also consists of electrons that are surrounding the nucleus. Okay, so basically we need to know that inside the nucleus in an atom we have the protons and the neutrons, while outside the nucleus we have the electrons. In a neutral atom of a net charge 0, which means this atom is uncharged, the number of protons is equal to the number of electrons. We have 6 protons, 6 electrons. Usually, electrons can transfer from an atom to another. So, when electrons come from the outside to this atom, it will have more electrons than protons, so it will be negatively charged because the electrons are negatively charged while the protons are positively charged. So the net charge is now -1. If you add more electrons, which means more negatively charged, more negative charges, so 6 minus 8 is equal to -2. Now let's get back to the normal atom, which is to the neutral atom, which has a neutral atom, which has the net charge 0. If it loses electron, let us take 1 electron from it, it will become positively charged because it lost an electron. So losing an electron will make the atom positive, and gaining an electron will make this atom negative. Why do we need to talk about electrons and protons? Because they are charges. And do you know that charges can, the building up of charges is called static electricity? In this example, in this website also, I want to tell you that you can use phet.colorado.edu to practice this lesson. If you have a balloon, usually the balloon is in neutral because it has equal number of electrons and protons. But when you rub it to your shirt, for example, you can see that negative charges are building on the balloon. So the building of charges on the balloon is called static electricity. Now, because the balloon is negatively charged, it can stick to the positive charges of the wall, because negatively charges will attract positively charges, while negatively charged will repel a negatively charged balloon. Now, let us have these two balloons. Let me rub the first balloon in the shirt to make it negatively charged, and let us rub the second balloon to make it negatively charged. What will happen is that the two balloons will repel. Why they repel? Because like charges will repel, but unlike charges will attract. So positive and negative will attract, while negative and negative will repel. Or positive and positive will repel, while positive and negative will attract. So this is static electricity. Basically, static electricity is the building up of charges. So the building up of charges is basically called static electricity. Okay. Now, despite the fact that they are called static electricity, but static electricity is not enough to turn on your devices, your mobiles, for example, that you're using to watch me now, or your TVs, or your washing machine. So static electricity is not enough to make these devices work. Instead, we need electric current or current electricity. So current electricity is the energy of the movement of electrons, as you can see here, or movement of electric charges. As you can see here, the electron charges are moving. Okay, so current electricity is the energy of steadily moving electric charges. So look here, we have also this circuit, and to make a circuit we need energy source, which here it's a battery, we need wires, and we need the device that we want to work, which in this case also it's the lamp bulb. So as you can see here, the charges are moving steadily in order to build this current electricity. So the pathway of the electrons, as you can see, is called the circuit. The pathway of the electrons is called the circuit. Okay? Now, as you can see here, the circuit is closed. There's no opening between the wires. Because it's closed, the electrons can move. Now, let me try to separate the wires. No more charges are moving because the circuit is now open. So when the circuit is open, there will be the device that I'm trying to work on will not be working, while if I close the circuit, the device will work properly again. So current electricity is the energy of moving electric charges. When the electric charges are moving, we will have current electricity. And you need to know that the pathway of electrons is called the circuit. The pathway of electrons is called the circuit. So, only electrons can move when the circuit is closed. Only the electrons can move when the circuit is closed. When the circuit is open, as I will show you now again, the electrons will no more move and the device will no more work. Now we will talk about the parts of a circuit, which we mentioned some of them previously. So in order to make this circuit function, we need a battery, which is the energy source, we need wires, and we need the device to operate that we need it to work. So we know that electrons can move easy or more easily in some materials than others. Why? Because we have a resistance sometimes. Like friction resists the motion, we have the resistance of the wires, for example. They can sometimes resist the movement of electrons. If I will increase the resistance, okay, look what will happen to the speed of the electrons. The speed will be less. If I will reduce the resistance, the electrons will move faster. And when the electrons move faster, when the resistance is less, the light will be bright. But when I increase the resistance, as you can see here of the wires, the light bulb will be less bright and the electrons will move less freely. They will move slowly. Okay, so we need to know that resistance is the measure of how much the charges are being opposed by the flow of current, of electric current. So the wires, sometimes they opposes the flow of the current. Okay, anyway, we need to know as well that there are conductors and insulators for the electric circuit. Let us try to experiment some of them. In this example, I can choose from the list here, for example, a paper clip. Let me check if the paper clip is an insulator or conductor. It is a conductor. So what is a conductor? A conductor is, it allows the flow of charges, while an insulator will not allow the flow of charges. So let us check. For example, eraser, for example, it will not allow the flow of charges. So the circuit will not be working because there's no current electricity. Okay, there's no current electricity. So the eraser is called an electrical insulator, while the paper clip is called electrical conductor. So electrical conductor, it's a material that allows the electron to flow easily, while insulator is a material that will not allow the electrons to move easily. Okay, so we need to differentiate between conductor and insulator, and we need to know what is the meaning of resistance. It opposes the flow, like friction resists the motion, and here resistance in circuits will resist the flow of electric current. Okay, now we need to know, let us remove the insulator. we need to know that the light bulb has resistor as well inside. So what happens is that the resistor is a device, as we mentioned, that limits how many electrons can pass through the circuit in a specific time. So resistors slow the flow of electrons through the circuit, and they can also change the electricity into thermal energy. Thermal means heat. If you touch or if you look at your light bulb, if you try to be even to put your hands close to it, you will feel heat, because the resistance the resistors are or yes, the resistors are changing the electricity into thermal energy. And the resistor in light bulb is not only changing it into thermal, but also it's changing it into light, because we're getting light from the lamps. So the resistors in a lamp are changing into thermal and light energy. Okay? So the battery also can be called dry cell or electric cell. The battery, another name for the battery, is called electric cell or dry cell, which is a device that contains chemical energy, but this chemical energy is being changed into electrical energy or current electricity. So the battery or a dry cell or electric cell is changing chemical energy into electric current or current electricity. Okay, as you can see here. Okay, now it's time to discuss a bit about parallel and series circuits. Now, let us try to add some wires and to add another light bulb to our circuit. So I will use more wires. As you can see here, I'm using more wires to build another circuit, or to continue the circuit, to build another a pathway maybe. Okay. So as you can see here, I'm using wires to build another electric circuit, or to make more loops. If you can see now, I have two loops, loop 1 and loop 2. So you can see that the electrons are moving. Let me use the pointer. Yes, they are moving inside here. So I have the first loop and the second loop. Okay, so this is called a parallel circuit, because the wires, as you can see them, are parallel, and because we have more than one loop, we have two loops. What happens in a parallel circuit, like now, electricity at your home is basically built in parallel circuits, because if one of your light bulbs is off, the others are on. Yani you will not lose other lights. So similarly, if I cut the wire here, the other light bulb is still working. Okay, the other light bulb is still working, because they are connected in parallel, because they have different loops. So you can see that electrons can still continue their rotation. But let us remove this and remove this wire and try to connect this light bulb, for example, here. Okay, what will happen now here, that they are connected in series circuits. Now they are connected in series. Anyway, if you remove one light bulb, both will turn off, because the electrons cannot continue their flow. The electrons cannot continue their flow. So a series circuit is a circuit that has single pathway for electrons, while parallel circuits, they have different pathway, or more than one pathway. That's why a parallel circuit is better used at home rather than series circuits. So in a series circuit, it's made out of single pathway, while in a parallel circuit, it's made out of more than one pathway. In a series circuit, if one light bulb is broken, the other will not work, while in a parallel circuit, if one device is broken, the others will still function properly. Okay, guys, that's basically a brief about electricity. I will see you later in new videos, and please write me the topics that you like that you like me to be explaining or discussing with you. Write any questions down in the comments so I can answer you later on in later videos. I will see you later. Bye bye, guys.